Excellent. Thanks, Brandon. That was a great presentation. Yeah, what you said about the about improving the API for document integration is a great lead-in to our next talk, which is by Leon Thornton on third-party system integrations. So I'll hand over to Leon to take it away. And yeah, thanks everyone. We see some questions appearing in the Q&A. Yeah, keep those questions coming, and we'll start addressing those in about 20 minutes or so once Leon's done. Right, thanks, Leon.
Okay, well, thanks, Brandon, for that. My name is Leon Thornton. Greetings, everyone, from Charleston, South Carolina, in the USA. I'm an engineer with the implementation engineering team, and I'm delighted to talk to you today about Landfolio integration microservices and to present 3 use cases using those microservices. So are my slides advancing? I can't actually see.
Yes, sir, they are.
Okay. So excellent. In keeping with the theme of this user conference, which is new beginnings, let's take a look in the past at how we used to do integration services. So in the past, we used to we would develop a large bespoke development to do everything that the integration needs to do. These were often very time consuming and very costly, and we actually still have to do some of those, but we started discovering that all of these big bespoke integrations we were doing, even though each one was unique, we were actually doing the same kinds of things over and over and over. For example, we have numerous integrations where we have to add a line item to a payment action. We have numerous integration services where we have to add a row of structured data. And when we build these into a bespoke solution, that's adding 50, 100, 500 lines of code that have to be written and have to be tested. So several years ago, we started looking into how we might make use of a microservices architecture to do the heavy lifting in these integrations. So if we take that approach of using microservices, sometimes we still have to have some smaller bespoke development around the edge of the solution. For example, if we have to go out to a website and pull in some data from a non-standard website in a non-standard format, that's going to be bespoke. But each time we look at an integration, we think, how could we use microservices to reduce the time and the cost for this solution? Because you, as the clients, you don't want to pay a lot of money for a bespoke solution when there's a cheaper and quicker way to do it. Another nice thing about using microservices is that it allows us to do a better job of monitoring what's going on in the world. So if we have microservices installed anywhere in the world, we can now better monitor those services. So we have a monitoring service application, which monitors all the other services. It can tell us whether a given service is running or not running. It can tell us if the service is throwing errors or warning messages out to the service log. And all of these results are sent into a central dashboard that we can then use to, at a glance, tell what the status of our services are. This allows for rapid identification and resolution of problems. The idea is that we would like to know if a service is misbehaving. We want to know, and we want to be able to diagnose it and resolve it, hopefully before you know it, and definitely before your clients realize that something is happening. We can let you know later, hey, something happened and here's what we did to fix it. But we don't want you to call us and say, hey, something's not working. That's just not good. This is not perfected yet, but we are working on improving that. So you may be asking, what is a microservice? A A microservice is an architectural approach to software development that makes use of numerous small independent services which communicate over well-defined interfaces. So instead of having a big monolithic integration service, we break it up into little blocks. And then we can take these blocks and arrange them and connect them however we need to in order to create a larger solution. So each one of these microservices, it either performs an atomic task or it performs a collection of very closely related atomic tasks. What do I mean by an atomic task? Adding a line item to a payment action is an atomic task. Adding a row of structured data is an atomic task. But sometimes we find out that there are some tasks that are so closely related on the same Landfolio object that we can put them together into a single microservice. For example, if we need to, let's say we need to add a row of structured data, or we need to update a row of structured data, or we need to remove a row of structured data. Those are very closely related on the same Landfolio object, so we can put them into a single microservice. In addition, each one of these microservices performs its little task very efficiently. It makes use of a standard interface so that all of the microservices, they work the same way, they know how to communicate. Each microservice is self-contained, and it's actually unaware of the existence of other services. So this block does not need to know that this block exists, but it does have a way to communicate between the blocks. Each one of these microservices is well tested. So we write it, we test it, and once it's tested, we can use it in many different applications. We don't have to retest it every single time. So here I have a diagram of a typical generic microservice. It looks a little bit scary at first, but I'm going to step you through it so that you'll understand how it works. Every one of our microservices works exactly the same way. And you'll notice that there's some things, these two things here in red. These are the two things that we have to customize for you. Everything else is all part of the service, so we don't have to write it over again. So let's start here in the middle. We have a generic Landfolio object microservice. The service runs all the time. When it starts up, it pulls in the service configuration shown here in red. The service configuration tells the service 5 things. First of all, where am I getting my input messages? Number 2, where am I pulling the data to perform whatever it is that I need to do? Number 3, where is the Landfolio API with which I'm going to update Landfolio? Number 4, where do I put my service events? What log do I put my service events into? And number 5, once the service has completed for this particular task, what do I do with the message that I received? How do I dispose of that message? So everything that I've just said, the 5 things are on this screen. So I'm going to briefly take you through each one. So the first item is, where is the queue that I'm monitoring? So over here on the left-hand side, I have a input queue. An input queue is just an electronic listing of task assignments. Here's a task, here's a task, here's a task. The microservice will read the top task on the list, do what it has to do, and then dispose of the message. So where do these messages come from? Typically, they come from Landfolio webhooks or some other application. For those of you that don't know what webhooks is a core Landfolio application that is able to detect when certain events happen in Landfolio. If anybody is subscribing to that event, then webhooks will give a notification, hey, something happened over here, you're interested in it, go do what you need to do. It's a very complicated program, but it's actually simple in the concept. So let's say that that some event happens in Landfolio. Let's say an action is closed. Landfolio detects that the action has been closed, gets the audit record for that particular thing. and puts that audit record on the input queue for some microservice. The microservice receives the message and says, oh, I recognize this. I know what to do with this message because the service configuration told it what to do. The first thing it has to do is the second thing that is in the service configuration is where do I get the data in order to process this message that I just received? And that's where this custom view comes in. A custom view is nothing but a filter that gives us a predefined set of data in a predefined format. So the microservice pulls in that data, and then the third configuration item is which Landfolio API do I use to update Landfolio? And you can see that over here on the right-hand side. Landfolio, the microservice does what it needs to do. It updates Landfolio. All the time it is writing out to this service event log down here in the lower right. The service event log is just a log of everything that's happening within the microservice, and that is what feeds into our monitoring dashboard. Finally, the fifth configuration element is once I finish processing this record, what do I do with it? So if nothing else has to be done, I can just dispose of that record. But it could be that I want that record to go into some other service, so I can drop that record into a success queue, or if my service failed to process that record properly, I can drop it into a failure queue. Both the success queue and the failure queue are actually inputs into some other service. My service doesn't know or care what that is. It only knows that when I'm done, I put the record here, or I put the record there, or I throw it away. So that's how a microservice works. Once again, I point out that the service configuration and the custom view are the only parts that we have to customize. They're not terribly difficult. Everything else is already built into the service, and it's really nice. Okay, so with that, let's look at 3 case studies. I'll just go through these very briefly. The first case study is adding a payment line item using structured data. So in the past, I can remember a time in the very recent past where business rules, Landfolio business rules, could not interoperate with structured data. Now they can, but in the past they couldn't. So in this case, the client needs to pull values from structured data when creating a payment action for a final tax bill. So they want to create the action, but they want to pull the actual payment amount from structured data. In this case, you can see down here that we want to create a tax bill for 2028, and the payment amount is $230. So a bespoke solution to do this, back when it was not possible, would have taken about a week of dedicated effort. And the client doesn't want to pay for a week of dedicated development effort. So we come up with a better solution. In this case, the payment action was created by the business rule engine with no line items. So we have a payment action sitting out there with no amount. Webhooks detects that the action has been created. It takes the audit record, places it in the add payment line items queue. And then there's a add payment line items microservice that's reading that queue. It retrieves the message. It says, I know what to do with this message. I go out to a custom view. I pull in the value that I need. And then the microservice adds the payment line item and then discards the message when it's finished. So you can see down here at the bottom, we have a line item on the payment action that is payment final property tax for 2028 in the amount of $230. For this one, there was absolutely no bespoke code created. It was all done through configuration, and instead of taking a week, it took about 4 hours. The client was happy. Case study number 2 is a little bit more complicated. This one is creating and updating structured data. So in this case, the client maintains their project data in an existing commercial off-the-shelf non-enterprise low-code system. Basically, they have a project management software that they use. They like that project management software. They don't want to get rid of it. But the values that are in this project data need to be replicated in Landfolio because there are things that Landfolio has to do with that. We decided to replicate the project data in structured data. And a bespoke solution to do this would require about 3 to 4 weeks of dedicated effort, and nobody wanted to pay for that, so we came up with a better solution. So this is a case where we did have to do a little bit of bespoke development to go out to a website, request a report, get the report back, and dump it into a temporary integration table in our database. As soon as that happened, it sent a message to the managed structured data queue, and the managed structured data microservice picked up that message and then began going through and updating all the structured data nodes. So you can see down here that we have 5 structured data tabs. Each one has 8 to 10 to 12 data elements on it. And in total, I think there's like 36 fields that we had to update. What the microservice does then is it looks at each element in this table that just came in and each element in the structured data. If there is something that exists here but doesn't exist here, it creates it. If it exists here and it exists here but it's different, then the new data wins and it updates the structured data in Landfolio. And if both values are the same, it does nothing. It's a really nice solution, and it really makes the job easier when you have to do an integration of this type. And it worked really well, and the client was happy with it. Case data number 3, we have a client that wanted to create an open pit mine, and I've got a picture here of the mine, and you can see there's a little dot right down here, and if we magnify that, there's the dot. It's like a jumbo earth mover. So this is a pretty large piece of land. The problem is that there are people living on that land. They have their homes, they have their crops, and so the client needs to go out and collect compensation and resettlement data in the field using a mobile device and import that data into Landfolio for subsequent action. The process of importing the data to Landfolio creates numerous business objects and relationships between them. And we do want to avoid double data entry. We don't want to capture data on a device and then turn around and enter that same data into Landfolio. And a bespoke custom solution would be prohibitively expensive. So the solution was that we use Landfolio's mobile integration service to upload existing Landfolio data to a mobile device. And I've got a picture of the mobile device here. Perform data collection in the field, and then download that data into Landfolio. At the same time, we've configured quite a few microservices in what we call a daisy chain. So the daisy chain is where the output of one service is the input to the next service. And then as soon as the data is downloaded into Landfolio, we send a message to the create legal entity microservice. A legal entity is created. The output of that is that we send a record to the add legal entity as party to agreement microservice, which then adds the legal entity to the party. And then there's a create payment action, and then adding line items to the payment action. And all of these are arranged in a daisy chain. It's turned out to be actually a really nice solution for this client. So I've got a list here of all of the microservices that we currently have. I won't read the list to you, but understand that for each type of Landfolio object, we need a microservice that can create the object, that can read the object, that can update the object, or delete the object. So this list is not complete. As we go on, we find that there are other things that we need to be able to do. For example, we don't yet have any microservices for work accounts, but we're going to need one of those pretty soon. So we build this list as we go along, but you can see everything that we have so far. Key takeaways: microservices reduce cost and time to implementation. Each microservice is engineered to do one thing and to do it really well. Microservices do the heavy lifting and hide all the complexity from the person who's developing the solution. For each microservice, we test it once and we reuse it forever. Everything uses standard inputs and outputs. It's all about configuration rather than developing new software. We create custom views using standard structured query language. We can use daisy chains for more complex solutions. There may be some bespoke development required at the edges of the solution, and requirements analysis and solution design are always required. We still have to go through that step. And it turns out that sometimes the requirements analysis and design take more time than actually implementing the service. We have a monitoring dashboard for rapid response to issues, and all of the other tools in the integrations toolkit are still available. Sometimes we still have to do large bespoke solutions. There's no way to use microservices for that. And finally, here is an example of the monitoring dashboard. It's still kind of in its infancy, but you can see over here on the left-hand side, we have a list of clients, and across the top, we have a list of things that are being monitored. And then for each one, we have a green light or a red light. If the light is green, the service is clean. Otherwise, if there's something red, we have to go investigate what that is. Sometimes we know that it's red for a reason, but at least it's an indicator that we can respond to. And that is the end of my presentation. I have my contact information down there in the lower left. I would love to hear from you, answer any questions that you have. And with that, I will turn it back over to Mike.